In this lesson, let's learn about velocity and acceleration in differential calculus. 微分法、速度と加速度. First, look at the points moving along a straight line. There's a point P moving on the x-axis. Let x be the coordinate of point P at time t. Let x be a function of t, and let x equal f of t denote this function. The velocity v of point P moving on the x-axis at time t is dx dt, which is f prime of t, or in other words, the derivative of ft. The acceleration a of point P moving on the x-axis at time t is dv dt, which is f double prime of t, or in other words, the second derivative of f of t. Next, let's look at points in motion on a plane. There's a point P moving on the xy plane. Let the coordinates of point P at time t be x, y. In this case, x and y are both functions of t. The velocity of a point P moving on the xy plane along the y-axis, that is, looking from top to bottom in the figure, is the velocity along the x-axis, and is represented by dx dt. Similarly, the acceleration in the direction of the x-axis at point P is expressed as the second derivative of x. Velocity in the direction of the y-axis can be considered in the same way. Therefore, the velocity vector with x-axis and y-axis velocities as components, and the acceleration vector with x-axis and y-axis accelerations as components can be expressed as follows. The magnitude of the vector v is the root dx dt squared and the square of dy dt, which we get from the Pythagorean theorem. The magnitude of acceleration can be considered in the same way. Now let's do a practice problem. The answer is as follows. Here's one more problem. Let's try to solve it. The answer is as follows. Now let's review. The velocity v at the time t of point P moving on the x-axis is v equals dx over dt, which equals f prime of t. The acceleration a at time t of point P moving on the x-axis is a equals dv over dt, which equals d squared x over dt squared, which equals f double prime of t. The velocity vector, whose components are the velocity in the x-axis direction, as well as the y-axis direction, is vector v equals dx over dt, dy over dt. The acceleration vector, whose components are the acceleration in the x-axis direction, as well as the y-axis direction, are vector a equals d squared x over dt squared, d squared y over dt squared. The magnitude of the velocity is absolute value of vector v, which equals square root of dx over dt squared plus dy over dt squared. The magnitude of the acceleration is absolute value of vector a equals square root of d squared x over dt squared plus d squared y over dt squared squared. That concludes this lesson.